Covalent bond. Bond where one atom, sorry, let me rephrase that. Bond where two atoms share electrons. Bond where two atoms share electrons. Both are non-metals. So now we're talking about only the right side of the periodic table, everything on the right of the stair step. Covalent bond, bond where two atoms, both non-metals, share electrons. So previously we were giving away electrons, now we're sharing. So much nicer. I hope my kids are covalent and not ionic when it comes to their toys. All right.
No.
Glad that got recorded. So we have carbon and oxygen. Lewis dot diagram. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. Now we look at carbon, we confused at first because we think, why can't it just donate electrons? It's a non-metal. Non-metals do not donate electrons, they only share them. Alright? So, if this carbon shares an electron here, and oxygen shares one back. Look how nice that is. And let's say it shares here, and this one shares one back. Does the oxygen now have access to 8 electrons? Yes, it does. What about carbon? No. It has access to how many? 6. The 4 original, and 2 more. So we have carbon double bonded to oxygen. However, this carbon still needs 2 more electrons, right?
Mm-hmm. So you
now,
have another oxygen.
Yes. We're now well trained in the ways of bonding. You guys gotta make great marriage counselors. All right. So we share one, and we share one. We share one, and we share one. And now, does everything have access to 8 electrons? Yes. So I have carbon with double bond to oxygen on each side. All right, starting with naming. We're going to write the element farthest left and down on table first. So look at a periodic table. Is one of these further left or down than the other? Which one is further left or further down? Hello? Carbon. Carbon's further left than oxygen, right? So I'm going to write C, and then what? How many oxygens? CO2. Look, we made CO2. Good job, team. To name them, naming. Write the prefix for the number of atoms of each element before them. Before it. And there is an exception to this. Exception. Don't write mono for first element. Don't write mono for the first element. That's our exception. So let's look at those prefixes real quick. Most of them are going to be familiar because of the roots. Some of them you might know a couple different terms that we could use. All right, so 1, 2, 3, 4, 5, 6, 7, 8. What are some easy ones? What do we use for 8 things with 8? Oct, right? Octagon, octopus, oct. About 6, that's an easy one. Hex, right? It's an easy one. What about what about 3? Try.
2 is 5.
Okay. Some of these other ones are a little bit more difficult. Anybody know 7? We use 7. We almost always do the same thing. Hepta. Hept. Hexa, hepta, octa, 5, penta. And those are the ones that are pretty easy. 1, you might think una or mono, but if you think about chemicals you've heard of, would be mono. 1 is mono. Like monotheistic. We talked about polytheistic and polyatomic, multiple. Mono. All right? 2 is not bi. What's another thing we use for it? If I'm going to cut a word into pieces, or if I'm going to cut an animal into die, dissect, die, cut it into 2, die. Die in 4 is not the one that you initially think. You might think what? You might think quad. That is not it. Play the video game where you try to get 4-sided things to fit in. You get all bonus points. You get 4 at a time. I know some of you play that still.
No.
Tetris. Tetra. Tetrahedral. 4-sided things. Tetra. So if we look at this compound that we've made, we have carbon. Now, I have 1 carbon, so it would be monocarbon. However, we don't start with mono first. So it's just carbon. And then I have 2 oxygens, so it's
Carbon
dioxide. Carbon dioxide. Oh! Carbon dioxide.
That makes more sense now.
Right?
So it's like, where are they getting this dye from? Because like, get the oxide now.
Okay.
I'm pretty funny. I don't understand how carbon is the farthest left and down.
On the table, like on the periodic table, like it's farther to the left than each section.
All right.
Alright, Gilbert, if you had 7 things at one time, would you have the
Yeah. All right. Can we think of another one? Think of another one. Let's go with this. What if I had these 2 things in the presence of each other? How many would I need? 1, 2, 3, 4, 5. I have 5 on that and 7 on this. Okay. If I share 1 and I share 1 back, fluorine is what? Is fluorine good now?
Yeah.
Right? How many fluorines would it take to satisfy this? Share with it. It would take fluorines. You guys have gotten good at that. Need 3 electrons, right? We've gotten good at filling those voids. So if I have another fluorine sharing 1, another fluorine sharing 1, that's PF3. And we're going to call that what? Phosphorus. Phosphorus what? Trifluoride. Phosphorus trifluoride. We leave that first one the same, just like we do with carbon. We don't call it carbide, we leave it carbon. Phosphorus we treat like a metal almost. Phosphorus. It's not phosphide trifluoride, it's phosphorus trifluoride. We leave that first one the same. Just like we do a metal and an ionic bond.
Is this an actual thing?
What? That?
Yeah.
Sure. I think it is. Yeah. Phosphorus has some weird bonding it does too, though. I want to add one more definition, your last definition for the unit. diatom. Diatom. I just dropped my marker behind me. Hopefully I didn't write all over my shirt. Di means what? 2 atoms, right? 2 atoms. 2 atoms of the same element bonded together. Bonded together. Now, don't be confused. There are diatoms in biology too. So don't be confused when you get to biology class and you're like, hey, with diatoms, those are covalently bonded to themselves. You're crazy, Miss Fisher.
Is this where we do with the forks?
Huh?
Is this where we use the forks?
We just did.
That's like necessary.
All right. Diatom. So if I have an oxygen and an oxygen, and there is nothing else to bond to. There's no metal to take anything. These 2 oxygens will share an electron each, 2 of them each, and you have oxygen bonded to oxygen. What's the formula for this? O2, which is what we breathe. O2, and we're going to call this just dioxide.
So diatoms don't like you make sure you put the whatever the thing is in front of it, like the 1 through 8.
Yes. It's always going to be di because it's a diatom.
Yeah.
All right. So if I had 2 fluorines, for instance, it's a fluorine bonded to fluorine. That's difluoride. F2. Pretty much all of these can exist. Some are unstable, but pretty much all of these can exist as diatoms. Carbon quadruple bonded to carbon, dicarbide. Fluorine bonded to fluorine. Oxygen double bonded to oxygen. Phosphorus triple bonded to phosphorus. They're going to be di whatever ide. Now, hold on, don't pack up. Give me one more second. The only other thing you need to know is that they will sometimes, no announcements today, sometimes we'll just call them fluorine or oxygen or carbon when they're diatoms because we know they're bonded to themselves because they're not bonded to anything else. Because fluorine doesn't just float around looking for electrons. Ooh, I need electrons. Anybody got one? So they will exist bonded to themselves. So we just call it fluorine. So technically it's difluoride. We usually just call it fluorine. All right? Stop there.